Welcome back to part 2 of the first lesson on the halogens. Okay, so this is a classic kind of table you get in a question, looking at the halogens and asking to look at the trends, the patterns in the data. So the first thing I'm going to do when I look at this table, I'm thinking, okay, I've got 4 elements here. Are they in the correct order? So I'm going to look at my periodic table: fluorine, chlorine, bromine, iodine. Yes, okay, so I'm missing acetylene at the bottom. I wonder what question they're going to ask me next. I'm missing I'm missing astatine. However, I do have the correct order. They're going in order downwards. Okay, so what about the melting point? Well, as I go down the group, my melting point is minus 220, minus 101, minus 7, it's increasing. Now, if you remember last lesson, I am absolutely hopeless at doing this. So here's my number line again. You can see I've got 0 in the middle there. And I've just put those numbers on. Okay, and I can see that as I'm coming down the group, that arrow is moving up towards 0 and then past 0. My melting point is increasing. So I could say, as I go down the group, the melting point increases. Okay, what about the boiling point? Well, as I go down the group, again, it's increasing. So I can just say, as we go down the group, the boiling point increases. Nice and easy. Now, what about this final column, state at room temperature? How many of you are having a panic attack right now because you've no idea what that means? You are not alone. Do not panic. Okay, so state at room temperature. This word throws everybody. All it means is the 3 states of matter. Is it solid, liquid, or gas at room temperature? Well, I don't know about you, but room temperature is a bit of a funny one. My room right now is 19.3 degrees. Yes, I am sad enough to have a thermometer right next to me. But your room might be a different temperature. What do they mean? Well, unless it says otherwise, you think of room temperature as being 20 degrees. So this question is, if we look at the first one, what state is fluorine at 20 degrees? Is it a solid, is it a liquid, or a gas? Now again, and I am not faking you out, guys, I'm totally serious. This is something that confuses me, so I have to have a little trick up my sleeve to help me get through this. So I'm going to teach you my little trick and hopefully it will help you too. So let's have a look. So you can see here I've drawn a couple of lines and I've labelled my first line melting point and my second line boiling point. Okay, and you can do this if you're in my class normally, you'll see me scribbling this on the board. Usually I have to climb on the top of the cupboard to reach the whiteboard. But I do this, and I would also do this in an exam. I would also do this when I was preparing this lesson on a piece of paper, quick scribble, so I've got it in front of me. Now, melting point, what does that actually mean? Well, melting, if something's melting, it's going from a solid to a liquid. So I've put solid on the left, and then I've put liquid in the middle there. Boiling point, if something's boiling, it's going from a liquid to a gas. If you boil water in a kettle, you start off with liquid water, and you end up with steam. So I can see where my solid becomes a liquid and my liquid becomes a gas. Now I need some numbers. So I'm going to look at fluorine first. So I know the melting point for fluorine, it tells me, is minus 220. And I know my boiling point for fluorine is minus 188. Now if I consider those two numbers on a number line, where is 20 degrees, plus 20 degrees? Well, it's somewhere way over there, isn't it? Way beyond 0. So at 20 degrees, what is fluorine? Well, it's already melted. It's already boiled. It must already be a gas. Okay, so fluorine at room temperature is a gas. And actually, think back to what we were just talking about. I showed you a picture of fluorine as a yellow gas. So it makes sense, doesn't it? Of course it's a gas. Okay, let's have a look at chlorine. Okay, so chlorine, again, you notice I'm going to have to change my numbers because we're talking about a different element here. So chlorine has a melting point of minus 101 and it has a boiling point of minus 35. Again, where is plus 20 on that number line? Well, again, it's over here, possibly not quite as far away as before, but it's after the minus 35, isn't it? Minus 35 is well below 0, and plus 20 is above 0. So it's gone past my melting point, it's gone past my boiling point, and I am a gas. Okay, if you're pretty confident here, stop the video, have a go at the final two yourself and have a go and see if you can do it. If you're still struggling, stick with me. Okay, so let's look at bromine. Hopefully you've had a go yourself. So melting point I know is -7 and boiling point I know is 59. Where is 20 degrees on that number line? Well, it's somewhere around here, isn't it? It's between the -7 and the positive 59. So bromine at 20 degrees is in that liquid area, isn't it? It's a liquid. And again, if you think back to the picture, you can see it's a liquid. And finally, iodine then. So a melting point of 114 plus 114 and a boiling point of 184. Where is 20 degrees on that number line? Well, it's well before 114, isn't it? And therefore I am in the solid area there. So iodine at room temperature is a solid. And again, that picture that we showed you earlier should stick in your head and think, well, of course it is, Mrs. Newsom, what are you on about? Okay, so what's the trend? Now, again, you can't really say it increases or decreases, can you? It doesn't make any sense. So what would you say instead? Well, probably something along the lines of, as we go down the group, the states change from gas to liquid to solid at room temperature. Now, what's the next question? You can feel it, can't you? What's the next question they're going to ask you? What about astatine? What can you predict about astatine? Well, I know that astatine comes at the end of this group here. It's at the very bottom. And so if I'm following my trend through, we said the melting point was increasing, didn't we? And so astatine's melting point must be above or higher than 114. And if I was being really clever, I'd look at those numbers and think it's increasing about 100 by 100 each time. And so I might even guesstimate around 214. That would be a logical guess that the exam board would allow. Boiling point, again, it's going up, it's increasing. So I'd expect astatine would be higher than 184. Now that group in there, those increases are not so obvious, maybe a 40 each time, so let's say 224, something like that. You can see I'm not adding up here. I haven't done this on the calculator. I am just guesstimating. If you did it on a calculator, it might be slightly more accurate, but you can see where I'm going this. I'm making a logical guess. I know it's going to be higher than 184 and I'm guessing around 220. I'm not going to guess at 3000 because that just doesn't follow the pattern, does it? What about state at room temperature? Well, we said it went from gas to liquid to solid, and hopefully you'd recognise it's likely that astatine would be a solid at room temperature following that pattern along. And that is trends, and it is predicting trends using the trend you already have in using the halogens. So what do we know about the halogens so far? Well, we know there's a colour trend, okay, and you need to know these colours: yellow, green, reddy orange, grey and black. They're non-metals, they're poisonous gases or poisonous substances, and they form a -1 ion. And we know there's lots and lots of trends that we talked about as we go down the group. Most of them you don't need to know by heart, but you do need to be able to look at the data and say what's happening and then predict what happens next.